Ha, sorry. All this time I realize I've been talking and you couldn't hear me. Isn't that the classic story of the pandemic? Sorry, you're on mute. Anyway, hopefully you can hear me now. So yes, if you are able to hear me, please say hello. Please say hi in the chat. And it's lovely to have that interactivity. And it's for a few things. One, slightly selfishly, it is for my benefit because I feel a little more engaged and connected, and so I kind of know that you're there, and I'll teach a little bit better. But also, it's good for you to be fully engaged because remember, we want to be active learners and not passive. Okay, people are saying good morning and sound and all that good stuff. Okay, so let me throw some extra time on the clock there. So here is a Top Hat question that I'd like you to answer, kind of reviewing some stuff that we did last time. And for some reason, it said it was closed. That's all right. We will open it again. So yes, this is a Top Hat question that will remind you or get you to think about some things that we were talking about last class. While you're answering that question, I will also direct you to a news item on the course website. So again, the course website really is your home for a lot of important stuff. If you go to the course website and to the news section, you'll see that there is a page where we're saying that we're going to delay the start in our labs. Our engineering computing services people have been working very hard indeed to try to help us get our labs up and running, but unfortunately they do just need a little more time. We might have been okay for Thursday, but we're not okay for today or tomorrow. So labs will not start this week as originally planned. Instead, labs will start next week. However, it's not just going to be a nothing. So we are going to do something instead of the lab. So in those time slots, in your regularly scheduled lab time slots, we are going to have a drop-in session. So if you have your hardware and you want to bring it and check and make sure that it's all good and that we can install some stuff on it to make sure that it works for the lab, you're very welcome to do so. The lab instructor will be there. I'll be there when I can. And of course, we'd also just love to meet you and actually say hi and see you face to face. But yeah, so that is something that you can do. We are limited in how many people can be in the room, but 20 people, as long as 20 people don't all show up at exactly the same time, I think we'll be okay. Reminder that everybody is required to be vaccinated to be part of the course. If you hadn't declared and showed your vaccination status, you wouldn't be in the course. You would have been deregistered. And everyone is required to wear masks on campus in public areas. Okay, so that Top Hat question that I was asking you said, please tell me about syntax and semantics. Something I'm going to do, by the way, is especially for the sake of the people who might not be able to watch synchronously. I know some people are in different time zones and are still trying to get here and stuff. When I ask you questions in Top Hat, at least while we're doing this online, I will also open up the questions after the fact as homework. So if you don't get it by the time that I close the question, it's okay. You'll still have a chance to do it. I forgot to do that on Friday, sorry, but those Friday questions are now open. Okay, so let's have a look at people's responses. Okay, so people mostly said that syntax was the well-formedness of language, things like objects and subject-verb agreement, adjectives, all that kind of stuff. And people said that semantics, mostly people said that semantics was the meaning of language, what a certain set of words are agreed to mean. And those are mostly correct. So actually, it looks like about 50% of people had correct answers. Some people had some different things. So syntax is about the rules of language, what makes up valid language, and semantics is what it all means. And so both of those are really important. We couldn't convey semantics without syntax, but on the other hand, we should remember that kind of the main point of the thing is semantics. The whole point of language is to convey meaning. And that is true whether we're talking about natural languages or programming languages. So last time we started talking about programming languages, and last time I actually had you write an expression. It didn't have to be a very complicated expression, but I said, please, for exercise 0, submit some kind of expression. Some people may have chosen to make a very complicated expression because there was that leaderboard in Gradescope that said the more complex your expression, the higher your score on that. No extra points or anything. Exercises are not about right and wrong answers. They're just about doing something and doing the work. However, and normally we would not condone making things more complicated than necessary, but it was just for fun. So hopefully everyone had a chance to submit something to exercise 0. And so you wrote an expression, and an expression in this case could be as simple as writing an expression like, 42. Or it could be 21 plus 21. Or it could be 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus, I'm getting tired of this, so let's say 38. And that's, not quite right. There we go. And so just like mathematics, we can use values and we can use operators to make an expression. And so you did that, and you wrote an expression, and that expression was evaluated. So evaluation means we take an expression and we turn it into a value. A big, complex, potentially expression gets reduced to a single value. So someone says, I tried to put in 21 plus 21 but didn't get an output. Is there a solution to this? So it depends what you mean by put in. Depends where you put it. So if you type 21 plus 21 in this kind of interactive Python interpreter. So that is a place where you can have an interactive conversation with Python. Hello, Python, how are you doing? Pretty good. Okay, 21 plus 21, and it should indeed tell you 42. When it comes to submitting an exercise, or later, when it comes to submitting an assignment, I'm going to get you to save a file that contains something like an expression. So 21 plus 21. Now, if I save this file, it's not going to print anything. It's not going to say 42 anywhere. But when you upload it to Gradescope, Gradescope will take your expression and evaluate your expression and see what the result is. Now, that doesn't seem like a particularly important distinction yet, based on what we've learned about Python so far, which of course is not very much yet. But by the time we're done today's class, you should see why there is that important distinction between evaluating an expression right now and writing an expression for somebody to evaluate later. There is an important difference between those. So I hope that's helpful. Oh, sorry. I meant to be typing something. Okay. So yes, I had meant to show you that screen in which you could see lots of stuff, including code. But anyway, sorry. So when I was talking about this window down here, this is the one I meant. And when I was talking about this window up here, that's the one that I meant. So sorry for that complexity there. Okay. All right. So that was what we did last time. And now... well, actually, no. Even last time we got into the question, what is an expression? So, what is an expression? What do you think an expression is? In your own words. All right, so an expression, whether it's mathematical or programming, is used to convey a particular meaning. It's kind of like commands, sort of, yeah. It's sort of like a series of numbers as a result. It's related to an equation. An equation is actually an expression and another expression and an equal sign in between. So an equation is more than just an expression. Okay, a relationship between quantities. So we'll get more into relationships, things like equality and inequality, a little bit later. So someone said a set of numbers with operators, and that's so close. But I want to avoid the word set because later in the course we're going to see that a set is a particular kind of data structure as well. But we're kind of circling around the thing, which is in algebra, an expression is values and operators that evaluate to a value. So to evaluate something is to turn it into a value. The clue's in the name, evaluate. That is what an expression is in algebra. And in programming, it's the same thing. And it turns out that expressions in most programming languages look very, very much like expressions in mathematics, even down to the level of things like operator precedence. So, if expressions are values and operations that evaluate to a value, let's look at some of those words in a bit more detail. Let's consider each one of those in turn so that we can really deeply understand the semantics, the meaning of expressions. And then once we really understand the meaning of them, we'll be able to use them much more comfortably and we'll be able to converse about them and do things with them. Okay, so values. What are values? Or rather, how can we get values? So in Python, for now, there will be other kinds of values later, but right now we're just going to talk about one kind of value, which is a literal value. And can you guess what a literal value means? And it really is just a guess, so don't worry if you don't get the right answer because, well, at this point we're just kind of guessing. Right, so a number would be one kind of a literal value. Yep. So, literal values literally mean what they literally say. And there are several types of these literal values. Or as they would have said when I was living in the UK, literally. The first day we were in the UK, my wife and I went into the bank where we were getting a new account. And the guy was like, I'm going to get you to literally type in your PIN right here. I was like, okay, I wasn't intending to type in my PIN figuratively or analogically. But anyway, they love the word literally. Anyway, so I literally typed in my PIN right there, and that literal PIN pad. But a literal literally means what it literally says. So an example would include something like an integer literal. So you've already used this when you did exercise 0. You submitted something that might have just said 42. Well, that is literally the value 42. And that is, in fact, an expression. It's a very simple expression. We have values and operators. Well, we didn't need any operators, so we had one value and 0 operators, but still, it's an expression. 42 is what we call an integer literal because it has a literal meaning of an integer value. We have, somebody said in the chat, strings. Yes, exactly. That's another kind. So we have integer literals. We have real number literals or floating point literals. So 3.14 is not an integer. It is, in fact, a real number. Is 3.14 rational? It's a quick little question for you. Is 3.14 rational? We've got yes and no. And it's a slightly tricky question because pi is not rational. But 3.14 is, right? 3.14 is just 314 divided by 100. But of course, when I ask the question, everybody thinks of pi, and pi is not rational. So whether you said yes or no, you could have a good reason for either answer. So. Somebody said that exactly, actually. Pi is irrational, but 3.14 is rational. Okay, good. So we have integer literals, floating point literals. We also have string literals. So strings are sequences of characters, and those characters are things like, in this case, HELLO, something you could type into a Wordle. Well, no, something you could type into Wordle has to be 5 characters long, but we can have strings of arbitrary length, very long strings. We can have very short strings. So let's see. Now I'm actually going to bring up the thing that I meant to bring up. Sorry. So give me an example of an integer literal. Someone. Now I'm going to get all of your favorite numbers. Well, maybe not. Maybe your floating favorite number is real. Okay. 10, 6, 5. These are all integer literals. How about a floating point literal? How about some float? Okay, 4.5. There we go. 6.2. 6.2, 3.2, 7.8. Oh my goodness, so many numbers flying past, I can't even keep track of them all. Notice, by the way, that when I type 3, it says, yep, that is 3. When I type 3.0 and press enter, it prints something different. It says 3 and 3.0, but aren't they the same value? Well, 3 and 3.0 might have an equivalent value, but they are different types of value. One is an integer, one is a floating point number, and that's going to become important as we go on further in the course. Strings could be anything. So, like I said, hello typed in quotes, or my name is Kid Rock. No, definitely not. My name is Jonathan Anderson. There we go. Or we could say hey or sup. There we go. So we could have nice short strings, we can have longer strings, and we're going to see there are several ways to write strings. So we can have integer literals, floating point literals, string literals, and finally, logical or Boolean literals. They're called Boolean because there was a fellow named George Boole who described a lot of the rules for logic that we use in programming. And so a logical value is either true or false. So a logical literal is either true or false. And this is as good a place as any. Somebody put a heart on 5.9. Apparently somebody really likes the number 5.9. Not entirely sure why. I recognize the significance of a couple of numbers that went by. I think one was a weed reference, but anyway, that's fine. But this is as good a point as any to mention that if I type true, T-R-U-E, with a lowercase t, Python is going to complain at me. It's going to say, what's going on here? That's an invalid name. The name true is not defined. In Python, first of all, the language is case sensitive, as most programming languages are. So lowercase x and a capital X mean different things. In Python, we spell true and false with a capital T or a capital F. That is something that's actually a little bit different from some programming languages. Lots of programming languages spell true and false with lowercase t or f, but Python spells it with an uppercase t or f. Okay. So those are 4 types of literals. And remember, literals literally mean what they literally say. There we go. So we've seen integer, floating point, string, and logical or Boolean. Wow, we have many emojis on 5.9. Okay. I wonder if that's just because I said, interesting that somebody hearted that one, or if it is because there's in fact a significance that that this old fart just completely misses. I don't know. Anyway, so let's look in a little bit more detail about some of these literal values. So integer literals. I mean, it seems kind of straightforward. I asked you, what's your favorite number? And a bunch of people typed out, integers, and you typed them pretty well. So kind of like in math, we can just write a sequence of numbers, a sequence of digits. And of course, it is kind of interesting that when you type the number 1 followed by the number 0, where 1 is a small value and 0 is nothing, and you press enter, that gives you a number which means something more than the digit 9. So this seems super obvious to us now, but when you think about back in grade 2 or something, when you were learning about the place values of numbers, that might have seemed a bit odd. We'll actually come back to that later in the course when we talk about different ways to represent numbers. This decimal representation is not the only way that we can represent numbers, and in programming, we often use other representations as well. Okay, so we can write things in an ordinary decimal representation. Python also lets us do things that are kind of a bit odd in that we can use underscores to separate groups of digits. Now, not all programming languages allow you to do this, but Python does. So if I want to write the number 1,000, I can write it like that. If I want to write the number 1,000,000, I can write it like that. If I want to write the number 1 billion, Can I write it like that? Oops, no, I made a mistake, and actually I just wrote 100 million. But it's kind of hard to tell, right? So just like when you're writing digits out by hand, sometimes it can be helpful to use underscores instead of, so if you were writing this number by hand, you might write 1 comma, comma. In Python, you can use an underscore to do the same kind of thing. But here's a tricky little thing, and at some point, I'll probably ask you this as a small question on an exam somewhere. If you want, you can write that number. So the underscores can go absolutely anywhere that you like. They don't have to go in the thousands place and the millions place. I think that's partly so that you could write things like, there we go. So you could write a phone number. Now that's my office phone, not my personal number or something, but and generally people don't call me very often, so if I start getting flooded with calls from the internet, then well, I'll know that was a bad idea. But anyway, I just put my phone number on the internet. But yeah, so you can put the underscores kind of wherever you like. All right. So this representation kind of just looks like math stuff you've seen before, an ordinary decimal representation. This kind of looks like a decimal representation, except you can put underscores in it, which might help with really big numbers. You can also write integers like this. And this is the point where you might say, all right, I don't quite get what's going on here. 0b10, 0o10, 0x10. What? The good news is we don't have to understand that yet. We will come back to it later in the course when we try to understand the different ways that computers represent numbers. So we'll see that this is a binary representation, an octal representation, a hexadecimal representation. These things are actually pretty important. Well, at least the binary and the hexadecimal. People use octal a bit less. But we will park that for now. We'll come back to it right at the very end of the course when we talk about number representation. For right now, what we really need to know is that we can write integers like this, and we can write integers like that. Now, if you want to explore on your own, you're very, very welcome to, because I definitely encourage exploration. Okay, so that's integer literals. Now let's talk about floating point literals. So we had this earlier. Is 3.0 the same thing as 3? Well, sort of. I mean, they have the same meaning in terms of quantity that gets represented, but they have different types because they have different possibilities. So you can add a little bit to 3.0 and make it something that is different from what if you add a little bit to 3. If you add a little bit to 3, the smallest change you can make is to make it 4, whereas you could make 3 be 3.1, or you could make it be 3.1415927. Yeah, and notwithstanding whatever Professor Frink might say, and that's perhaps a slightly dated reference at this point, I don't know. Does anybody here know what Professor Frink is? Or who Professor Frink is? Maybe not. Pi is not exactly equal to 3. There's a question, why couldn't you write 1, 0, 0, 0? Yeah, okay, he was a Simpsons character. He stormed into, he needed the attention of a whole bunch of physicists in a convention or something, and he stormed into the room. He said, everybody, I need your attention. Quick, quick, there's something coming. And they're all just babbling and not listening and stuff. And he said, this is really, really important. And nobody cared. And he said, pi is exactly equal to 3. Room went silent. He's like, I'm sorry I had to do that, but extreme measures are called for. Anyway, yeah, there we go. Someone says, Cleveland. That's right. Yeah, so pi is not exactly equal to 3. So we can write numbers in Python using decimal places, and we'll get floating point literals, which has a floating point value. And we can also use scientific notation. So if we come back over here, I could write... Well, maybe, yeah. So I could write 10,000.0, or I could write 1E5. Oops, sorry, 1E4. And I get the same result. Off by 1 errors are very common in programming. So whether I write 10,000.0 or I write 1E4, I get the same thing. Or, of course, I could write 1.234E56. and that's going to give me a huge number, 1.234 times 10 to the 56. And so Python will use scientific notation where it is appropriate to, when we are printing floating point values to a screen, scientific notation will be used as appropriate. The way that the number is actually stored in the computer's memory, it doesn't quite look like this. It looks like something else. But again, we'll get to that at the very end of the course. Okay, so literals, integer literals, floating point literals. We can also have imaginary literals. So if you put a number in front of the letter J, and here's a place where, hooray, Python did the right thing. They did things the engineering way. So instead of the letter I, which is very commonly used in engineering to mean current, but it's very commonly used in programming to mean an index, in Python we have a J. So if I want to write an imaginary number, I can write 1.0J, or I can write 7.9J, or I can write 12J or negative 14J. And you'll see that the result is an imaginary number. Now that literal value that I've written here is not actually a complex number. It's not a complex literal, it's an imaginary literal. If you want to write a complex number, like 1 plus 2j, then you write an expression, 1 integer literal plus 2j, imaginary literal. All right. Any questions about that so far? No? All right. So let us... the other thing apparently I've missed here is string literals. Oh, look at that. I missed my slide on string literals. Sorry. So in that case, let me just type some things in and show you, and then we'll ask you a top hat question to see if everybody is still awake. And my word, the emoji are still coming in on the 5.9. Lots of emoji. How funny. Okay, so string literals, we can type, like I said, a collection of characters like hello, and those can be inside of single quotes, or they can be inside of double quotes, or in fact, we can put them inside of triple quotation characters. So either 3 single quotes, what is up, or 3 double quotes, what is up. The reasons for the triple thing we'll kind of get into a little bit later. But if you're going to write a string today, you're probably going to put it in either single quotes or double quotes. Why would we want that flexibility of being able to write it in single quotes or double quotes? It means exactly the same thing. Any thoughts? Why might we do that? Well, several people are typing. Because so easier to read might be one. Yep, because in some cases, let's say I wanted, so it's not very common that someone will say, hey, what is up? I mean, maybe. Someone says that I have the same question. What would I say instead? Typically, if I were trying to hang out with the cool kids. So I probably wouldn't say what is up. So much typing. Yeah, okay, so sup would be one thing, or even just slightly contracted would be like what's up, right? But let's say that I type single quote, what's up? The syntax highlighting, the coloring that Thani has given us a clue about the problem here. What's the problem there? Yeah, there we go. So somebody said in the chat to separate the difference between using apostrophe. That's kind of it. So if I have what's up and I have a string and I want that string to contain an apostrophe, well, I better not use single quotes around my string because look, Python will think the string starts here and ends there. And then there are these other like random characters afterwards. That's not what we want. So we can use double quotes around our string, and now it is a string that contains what's up. with a single quote in it. So sometimes we like to use single quotes in text. Sometimes we like to use double quotes. So whichever one you're using, that should not be your string delimiter. That should not be the thing that tells Python, here's the beginning of my string and here's the end of my string. So Python allows you to use either single quotes or double quotes because, well, sometimes it depends on what's inside the string. Now, if I'm using a word like hello, then it doesn't really much matter. I can use single quotes, double quotes, it doesn't matter. Someone asks, is it just safer to always use double quotes? Most people will tend to use one of them most of the time unless they have to do something else. Because what if I want to say, and then the instructor said, good morning. Well, in that case, I wouldn't want to put that inside of double quotes. So sometimes we have strings that contain single quotes or double quotes, so Python lets you use either. It's fine, whichever kind you want to use. Some people do, and some style guides actually recommend that you always use double quotes unless you need to use single. It's up to you. And yeah, triple quote is also a possibility. You can put, if I had this string, and then the instructor said, good morning, I could put that in triple quotes. And then the instructor said, good morning. There we go. And so I could do something kind of like that. But we tend to not need to worry about that too much, especially at this level. Okay, so those are literals. So that's one kind of value that we can have. And the next kind of value that we can have is variables. So literals literally mean what they literally say. Well, variables are names for values. Now, it's a little more complicated than that, but that is close enough for now. Later, we'll talk about how we create variables. For now, we're going to kind of focus on how we use variables. But before we do that, sorry, I meant to ask you a Top Hat question, and so I'm going to do that now. So tell me, which of these are Python literals? Some of these are, and some of these are not. All right, lots of answers are coming in. Oh dear, people are saying that they can only select one. All right, let me just stop this and modify it for a second. Okay, and restart it. There we go. Now you should be able to pick all of the options. Okay, so someone said MSL having buffering or lag in the YouTube live. So there's buffering, which is where it stops and kind of says, and then there is the delay that we can have because I say something and it takes a few seconds for it to get through the processing pipeline. So let's try this. I'm gonna try reading. I'm gonna say some numbers, and you tell me when you hear the number 0. So ready? 0, 1, 2, 3. Okay, that's not bad. 3 seconds. All right. If you can only You should be able to select more than one option now, but if you can only select one, that's okay. I'll reassign it as homework afterwards. Oh, interesting. So 3 seconds for someone and more like 4 or 5 for others. Huh. All right. So I'll close this question in just a second or so, or a few seconds. And if you can only answer one for now, I'll reassign it as homework, and we'll make sure you don't lose marks because you can only pick one. And by the way, for Top Hat, a lot of these questions, you'll basically get credit for doing the question at all, and then you get a little bit more credit if you get the right answer. So although you can do these together, it's okay. It's a good idea to challenge yourself to do at least some of them individually, just to see if you can get the right answer. It's a very low stakes way of testing yourself, and then you'll get a result. And if you get even if you get half the questions wrong in Top Hat, you'll still get at minimum 75% if you answer them all. And some of the questions, I'm not even looking for a right answer. I just want you to participate. Okay. So here we go. I'm going to close this now, and we'll see what answers people gave. Okay, so the first one, is that a literal? Yes, that is an integer literal. Then the next one, 1 plus 1, is that a literal? No, it is not. That is an expression. It contains literals, but it is not a literal. The next one, 1 underscore 0, 0, 0 underscore 0, that is a literal. Yep. 1j. So option D, 1j, yes, that's an imaginary literal. And good, fewer people said yes to this one, because 1 plus 2j we said is not an imaginary literal. That is an expression. It's a 1, which is an integer literal, plus 2j, which is an imaginary literal. All right. Hello is a string literal. What's up is a string literal. True is a string literal. A logical literal, a Boolean literal. False with a lowercase f is not. And finally, and is not. Okay, good. So it looks like people were getting mostly the right answers for these things. Good. So let's carry on then. So yeah, I see something in the chat here. If there was an error that you had, I will submit or assign these again as homework, and you'll have another chance. Okay. So we have literals, and we also have variables. And variables for now, like I said, we're going to just treat them as names for values. In that way, we're going to kind of treat them almost the same way as we do in mathematics, but we're going to see that there are some important differences between variables in math and variables in programming. So for now, we're not going to think too much about how to create variables. We're going to think about how to use them. So if there is a variable, so they will be in the assigned tab. Yes, they will be later today. All right, so if we have some variables that someone else has already defined for us, and one way we can get some of those variables is to type, now for now this is a slightly magic incantation string that I've got at the top, but by the end of the course we'll explain what it means. Let's say from math import star. So this means we're going to get a whole bunch of variables and other things in the math module of Python and make them available for our use. And that includes things like pi. So before I had a number 3.1415. Well, now I can just type pi, or in fact I can type e. E is another variable that exists in the math module because it's useful in lots of places. So now if I want to, I can type expression. Sorry, once again. I failed to change over to the view where you can see Thani. All right. So I typed from math import star. I typed the value of pi. I typed the value of e. Very good. And so now we can write expressions that involve these things like, well, actually, yeah, okay, fine. Let's type pi plus pi. We've seen plus before. And look at that. Pi plus pi is 6.283, etc., etc. And that sounds about right, doesn't it? Okay. So with these variables, we can write expressions, more interesting expressions. And so I'll come back to another example in a minute. So we said that expressions consist of values and operations that evaluate to a value. There was a question, does the J stand for anything in that string? In the string, yes. So having a number immediately followed by J, that's an imaginary literal. So that says that we are talking about 2 times the square root of -1. So that was back on slide, yeah, back here, 8 out of 18. Okay, so we have now talked about the values. So let's talk a little bit, which include literals and variables. So let's talk a bit about the operations. So the operations are used to combine in some ways, or you evaluate operations based on the values that they operate on. Okay, so let's start with really simple operators, which you already know, the arithmetic operators. So you can perform arithmetic, right? So we can write things like 1 plus 1, or we can do subtraction, so 3 minus 7. How about 2 minus pi? Okay, we can do multiplication, so pi times 2, or 2 times pi. You'll note that we are not using the letter x to mean multiplication because the letter x is a letter, it's a character. It could mean something else. It could mean the variable x. If I had a variable here that was already defined called x, and I said pi times x, then, well, that would mean that variable. Right. Another thing to notice, that we don't just write 2 pi or 2 pi with a space next to it. When we're when we're writing out multiplication on paper, sometimes we can use a mathematical shorthand. We might write 2 times pi with a multiplication symbol, a cross product symbol. Sometimes we might write 2 and a tiny little dot, pi, but usually we would just write 2 and then pi, or 3x, or 12x over 397 or something. But when we're writing and programming, we have to be a little bit more explicit. If we want multiplication, we have to say multiplication. Okay, someone's saying the name pi is not defined. That is because you need to type this. What we said is we're trying to stay as much as possible away from sort of superstitious magical incantations, but just for today, and well, we'll explain what this means later in the course, but for now I'm going to get you to type from math import star and then press enter. That will make a bunch of names available to you, such as pi and e. Okay, so we have arithmetic operators in Python. And the order of operation matters. And for now, all we're going to say about the order of operation is, or order of operations, is that it's the same as mathematics because we've got only simple operations. So we have parentheses, we have multiplicative operators, and we have additive operators. So just like for now, that is kind of the same thing. So let me ask you here another little top hat question. This is something that, aside from the fact that I'm using a slash and an asterisk, I mean, you almost don't need to be in a programming course to know the answer to this one, right? This is just math, but translating that programming syntax into math. All right, one answer has come in. Good. And again, try just computing this in your head, and don't bother with a calculator. Just try computing it in your head. If you get the wrong answer, A, no one else is going to see that you got the wrong answer, and B, it's a good opportunity to practice a little mental arithmetic, which is good for the brain. All right, more answers starting to roll in. This is good. Okay, so this one there's no timer on this one, so you should be able to answer this one still. All right, well, I'm going to close the question now, and it's okay if you haven't answered it yet. You'll still have a chance later when I set it for homework. So right now I will close the question, and we will look at the responses that came in. And so because this is a question with a floating point value, it gave a bunch of different possible answers but most people had something in the range of the correct answer. So there we go. There we go. So most people had the right answer. So very good. Well done. All right. One kind of fun thing to say about the division operator. So, when we write division in mathematics, or when you wrote division like in early grade school kind of thing, you might have written x divided by y like this, x with a division sign, and then y, or you might have written it with this other notation, which I can never remember which one is the quotient and the dividend and the divisor. Those are three words, and they apply to three different places in that particular operator. But there are different ways that we can do division based on whether we want integer results or floating point results. So what is 7 divided by 2? There's more than one way to get, there's more than one right answer here, believe it or not. But what is 7 divided by 2? Right, so 3.5, that is definitely one correct way to give the answer. What's another way to give the answer? Okay, 7 over 2. Yep, that's good. What else? Something that you probably did in grade 3, but don't think about too much anymore. Okay, 3.5. Yeah, so we can do it that way as well. So if we type in Python, let's see. And I remembered to bring up the Thonny window. Hooray. So if we type in Python 7 divided by 2, then we get 3.5. But there is another way to think about it, which is that 7 divided by 2, and this time notice I use 2 slashes, is 3. Well, in what sense is 7 divided by 2 3? Well, another way to think about 7 divided by 2 is to say that 7 divided by 2 is 3 remainder 1. So sometimes when we're dividing integers, we really want to have integer results. We don't want 3.5. We're really interested in knowing how many wholes and what is the remainder. So 2 divides into 7 3 times evenly, plus you have 1 left over. And sometimes that way of expressing math purely through integers, or expressing division purely through integers, is really important. So Python has a separate division operator for that. So if you type 7/2, you get 3.5. If you type 7//2, and notice, by the way, it's the same whether I put spaces around it or not. The spaces might make it easier to read for people. The computer doesn't care. So there's 7 divided by 2 integer division, and then I can also get the remainder using an operator called the modulus operator. So here you see that 7 divided by 2 can be expressed as 3.5, or 7 divided by 2 can be expressed as 3 remainder 1. If I have a much larger number, like 1 million divided by some large odd number, 751, okay, well, I can divide it that way, or I can say that is 1,331 remainder 419. So sometimes that's really important. Sometimes we want to know how many wholes and what is the remainder. Yeah, somebody wrote in the chat there, 3R1. Yeah, excellent. Wish I had seen that before I went into that whole spiel, because that is indeed exactly how we sometimes want to write these things. Another mathematical operator that some people have actually bumped into accidentally already when they've been doing expressions and things, and I've seen questions in the chat, is exponentiation. So here's a question. What's your favorite equation? Come on, you're in engineering. You get to have a favorite equation here, and nobody will mock you for it. We're all in engineering too. What's your favorite equation? Okay, E equals mc squared. Y equals mx plus b. Yep, that's pretty popular and used. Now I'm looking for an equation, not just an expression. An expression wouldn't have an equal sign. An equation has an equal sign. All right, for me, my favorite equation has to be Euler's relation or Euler's identity, which is that e to the j pi is equal to -1. What? Like, it's kind of mind-blowing, and I think it's beautiful. Anyway, if I want to write this in Python, I can use the exponentiation operator, which is, instead of a single asterisk, 2 asterisks. So I can write, if I want to say what is 2 to the power of 3, I don't write 2 asterisk 3, that means 2 times 3. I'd say 2 double asterisk 3, which is 2 to the power of 3. And incidentally, if I want to, so having done from math import star, I can actually write the value of one side of Euler's relation here by saying e to the power of 1j times pi. So that's e to the j pi. And look at that. It comes out as something very, very close to -1, but not exactly. So it says it's -1 plus something times 10 to the -16j. So that is -1 plus the tiniest little number that you can possibly imagine. There's another important thing happening there, which we'll get into more and more as the course goes on, that computers, when they do math with floating point numbers, make tiny little errors all the time. And those errors can add up over time. Now, if your error is 10 to the -16, that's okay. Most of the time, if we're right to 3, 4, 5, 6 significant figures, who cares? If we're right to within 15 significant figures, that's definitely close enough for almost anything that you can imagine doing. However, it is worth knowing that computers do have these tiny little errors. Okay. So that's time. So let's stop there. And when we continue next time, we will talk about comparators and we'll talk about Boolean operations, and then we'll get a little bit more into variables and things. So just as a reminder for everyone, there is this news item that's been posted to the course website. So go to the course website, news item. The delay in the lab start. So labs are not starting this week. However, you are very welcome to drop by your assigned lab slot if you would like with your equipment and say, hey, is this the right equipment? And could you help me get it set up? And we can definitely do that. And then we'll even get to, meet you, which would be nice. You don't have to. It's not required. And we wouldn't want more than 20 people to show up at a time, but that's probably not likely because we've only got 35 people in the largest section, and I doubt that everyone's going to want to be here, and especially some people are even still traveling. So that is an option. And also, based on what we've done now, you can see exercise 1 has been posted, and this is something that you should be able to start looking at doing. So exercise 1 asks you to write an expression that is just a little more complex. It assumes that you have, well, first of all, that you've read some description here, and you might say, what? I didn't get into engineering, so I could have to read. Well, sorry. This is information about a little civil engineering problem. We don't solve problems in programming just for their own sake. We write code that solves problems in lots of disciplines. So this is a little bit of information about a civil engineering problem, and then it says you may assume that we've got variables called L and X and angle and E and I, and you need to come up with what is the expression for the load on a cantilevered beam under uniform loading. If you were to find that, and this is not the right answer, but if you found that the correct answer was Q divided by angle, then you could write your expression as Q divided by angle and save that as exercise 1.py. We can talk more about that on Wednesday. This exercise is not due until Friday, and it should be a fairly straightforward one, so we can talk more about that on Wednesday. But you can also talk with me in the chat or send me email or however you would like to do it. So that will be it for today. So let's see, is that all engineering labs or just 1020? That is just 1020. So the issue is there's a brand new computer lab in the new core science building, CSF 2112, and it's almost ready. And engineering computing services have been working very hard on it, but they have not quite finished it yet because they have a lot of things that they were told, surprise, you have to do this and this and this and all this other stuff you weren't planning on. So they have a lot of work that they have to do. Hopefully it'll be ready by the end of this week so that next week we can start the labs. There's another question here. Does Visual Studio Code operate differently from Thonny? And the answer is yes and no. Sorry, that's like an academic's favorite answer. Visual Studio Code uses the same Python interpreter that Thonny does. So Visual Studio Code should give you all the same answers when you type things into the interpreter, etc. The programs do have different features and functionalities and stuff, but the way we're using them today, as of the stuff that we've got going on right now, they should behave basically exactly the same. The differences will only come in later when we want to like install extra modules and extra functionality and stuff. But for now, Thonny and Visual Studio Code should behave kind of the same way. And if you don't have any of these things installed, I would definitely recommend start with Thonny because it's very straightforward. Actually, start with one of the online options, and then just have a text editor like WordPad or Notepad on Windows or TextEdit on macOS. That's a great way to get started. You don't have to install anything then, and then move to get a little more advanced by installing Thonny, and then eventually you may or may not want to install something more advanced, but Thonny is getting more and more capable all the time, so it might be enough. Can we see the 10,000 point code? Oh, yeah, so somebody indeed had an expression that was extremely complex, and on the leaderboard it had 10,000 points. Let me just check and make sure that there's nothing kind of personally identifying in... Actually, someone's got one that's 11,497. Let me see. If I can open it in my text editor. There we go. Now that way there's no personally identifying information here, so I'm not identifying who the student is, especially on the internet. But yeah, one of these submissions looks kind of like that, which is a whole lot of 42 plus 42 minus 42 plus 42 minus 42. We had another one that looks like... And sorry, just taking a second to open that, where again, I just want to make sure that I'm not opening it in a way that reveals anything about the student who submitted it. Yeah, there we go. So we've got, some more expressions, some more complex things, but, that is, oh, sorry. There we go. So yeah, that's what I meant to show you. So lots of kind of complicated expressions here. Again, this is not the way that we would actually want to write a program in Python. We don't deliberately make things as complex as possible. However, for the sake of fun, it's, fun. So good job. So someone said 7 modulo 2 is equal to 1. Yes, that is true. So 7 divided by 2 is 3 remainder 1, which means that's 7. And then the modulus operator. So 7 modulo 2 should give you 1 in any Python interpreter, no matter what program you're using to run Python. Okay, yeah, someone's giving a hand clap to the people who had those big complex expressions. Well done. Okay, so at this point, we're well over time, and I guess the questions are kind of tailing off. So I'm going to stop at this point, and I'm going to go get ready for my next lecture, as well as a tutorial I'm giving this afternoon. And yeah, we will chat again. I hope to see, maybe a few of you tomorrow at some point. Certainly Ms. Hogan will be in the lab, and I'll try to drop by if I can. And hopefully I'll get to see at least a few people tomorrow, and then we'll all re-engage for this online lecture on Wednesday. So thanks very much, and have a lovely rest of your day.